Okay, welcome back. I hope you had a good break in between the videos. I grabbed some coffee, so I'm feeling rejuvenated. Oh my gosh. Okay, so here's what we want to do next. We actually want to do a t-test. Actually doing a t-test. Actually doing a t-test. Okay, so the nice thing about statistics, kind of from here on out, is that the actual test literally takes 2 seconds to do. The computer is very fast at it. We're very fast at programming it. There's not a whole lot that goes into it. However, it is the output and the conclusions that we make that are going to take some time. Again, not like hours and hours, but it will, we do want to kind of focus here on the practical conclusion and the overall interpretation of what we're about to get as an output. Okay. Now, let's go back to the PowerPoint just for a moment. Let me kind of scroll through here. Here is the code. Here's the function that runs a t-test for us, t.test. And then within there is all of this. You have a bunch of arguments that you can specify. Okay. Now, the cool thing about R, and let me show you, we'll go back, is that if I have a question about some function, I don't have to go back to my PowerPoint or Google it. I can actually come down here into the console, type a question mark, and then the function I'm about to use. And if I run that, it brings up this nice little help menu. So I've got students t-test, the description performs a 1 and 2 sample t-test on vectors of data, blah, 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 whatever. And then I've got the arguments and what exactly I need to put in there. Okay. So you can read all about this, all of the, sort of details about each argument. Thankfully, for this scenario, we do not have all too much to put in there. In fact, what we need to do is just an independent t-test. Okay, independent or 2 sample t-test. Let me put that 2 sample t-test. How do we do that? Well, I'm going to use this t.test function. Parentheses, open and close. I'm going to hit a space here just to make my life a little bit easier and more organized. And I need to put in 2 things, okay? Because we've got 2 samples. We're going to be using this wide version of the data because I've got 2 columns that I want to compare, okay? I've got the cross-fertilized column, and I want to compare it, see how different it is to the self-fertilized column, okay? As we saw here, whoops, here in the plot. I want to see if this difference is a statistically significant difference, okay? So the first argument I'm going to put in here is going to be the first column that I want to test, okay? So that's going to be from our plant data. And then I need the $ because I just want to grab the 1 column in here. I want to grab, let's just grab this first cross-fertilized column. So I'm hitting tab here and I can click on it. I can type it. I could do whatever. But there it is. Okay. And then I hit comma and then I just put in, I supply the next column that I want to compare. Okay. And that's going to be the self-fertilized column. So that's going to be from the data. And then I use the $ to grab inside the data specific column. And I use this self-fertilized. What else do I need? Well, for this 2 sample t-test, this is it. This is all the code you need to do some pretty intense math. Okay, it's very convenient. It's very nice. So if I run this, check it out. Check it out. It just ran a t-test. It compared the 2 It compared the 2 columns based on their difference, and it spat out everything that I need right here. Okay. So let me see. Is there anything in here that's new? No, there's not. Okay, so I'm going to go back to the PowerPoint here because I've got the same thing. Let me just make sure. Yes, okay, we're good. Okay, so this is what we saw in R. This is the output, right? It looks a little different because I've got it squished in the console here, but this is what we get. So we get the test that it's running. In this case, it's running a Welsh 2 sample t-test. Welsh is just another dude that made the t-test or improved upon the t-test. We're not going to worry about the details there. But what we are doing is comparing the difference between 2 samples. Okay, and we've got the data. Hold on. We've got the data. The first column and the second column. It kind of tells us what we are comparing. It's very nice. So let's just get into this overall output and see what each of these things mean. Okay, so we'll move on. Take it kind of one line at a time. So we have our t value. We have our t value, and this just tells us how far apart our two samples are from 0, or at least the difference is from 0. And it's done in standard error units. Don't worry about doing it anything more than what I just said. Okay, this t value is needed to calculate our p value. Okay, and also, we're not going to worry about the degrees of freedom here. Both of these things are needed to calculate the p-value, and we'll just say that's that. Okay. So the p-value here is used to determine whether there is a true difference between the things that we are testing, between the two groups. Okay. Now recall that we usually compare this value against a value of 0.05. Okay. And already you can probably tell that 0.02 is less than 0.05. So already we are able to say that yes, there is a true difference between these two groups in the whole population. Okay, and that's that. A lot of statistics would just boil down to what I just said there. Okay, now we're not going to worry so much about this for right now. I just want to show you what each of these things do and what each of these things mean and where to find them. Okay, so these nuts and bolts, very important, right? The p-value is where we make our conclusion. Okay, we'll move on, and let's look at this thing called the confidence interval. Okay, a 95% confidence interval. Now, what this p-value told us here, or at least the question that it answered, is there a difference? Not what is the difference, but just asking yes or no, is there a difference? Yes or no? Well, in this case, since our p-value is less than 0.05, the answer is yes, there is a difference. Okay, but since we're working with samples, we're not able to really say that, it is this difference, it is some value. We're not really able to say that. However, we are able to supply the range of values that difference can be in the whole population. It's pretty awesome. Okay, so the sort of cookie cutter sentence that you can give, and I'm okay with you giving this, is that there is a 95% chance. There's a 95% chance. We get this from this 95% confidence interval here, a 95% chance that the true difference in means, that the difference between the cross-fertilized height and the self-fertilized height is between these two values. So the difference in heights can be at least 3.8 inches and 4.82 inches. Okay, so that there's a 95% chance that the entire population of self-fertilized and cross-fertilized pea plants, the entire population, that difference we're going to see is going to be between about 0.3, 0.4 inches to about 5 inches difference. Okay, not the actual heights, but the difference in heights between these two groups. Okay, in the whole population. It's crazy to me. It is crazy to me that we were able to make that kind of inference about literally every single pea plant that is cross-fertilized and self-fertilized. Okay, so there is a 95% chance that the true difference in means lies between these two values. This is always the kind of sentence that you can use for these confidence intervals. Okay, we'll get more into the details of this in the future. And I think I have some Stat 2050 videos that go along with this as well, that kind of go into the more mathy side of it. But for now, we don't have to do the math. But if you're curious of how those are calculated, you can check out those videos as well. Okay, so this is a big deal. We get the p-value here telling us that yes, there is some difference, and we can be 95% confident that that difference is between these two values for the whole population, which is awesome. So again, I just want to be really clear here. This answers the question, is there a difference? And this tells us how much of a difference there is. Okay, very cool. It is so cool. Okay, and then we have some other stuff here too. So we have the mean of x and the mean of y. In this case, it's whatever we supplied to x and whatever we supplied to y. And it's just testing the difference here, right? So our difference is about, let's see, 3 point something. And we can see here that that is contained within our confidence interval, which is very cool. Now, there's another thing we'll get to in the future, but notice that this confidence interval does not contain 0, okay? So we are 95% confident that there is some difference and it's not 0, okay? And that's reflected in this p-value as well. Oh, man. Okay, so this is more out of convenience than anything else. Again, thank you, R. So that's it. Oh my gosh, that is it. So with one fell swoop, with one, well, I guess with 2 lines of code, but really just one, we could have put this, could have put it like this, and it would have been no big deal, right? With this single line of code, or these, depending on how you coded it, we were able to figure out so much information. We were able to figure out, is there a difference, a statistically significant difference between our 2 samples? And then what is that difference if we were to blow it up to the entire population? And we were able to say, well, on average, you know, cross-fertilized plants and self-fertilized plants will be this much different, okay, with a 95% chance of that being true, okay? So if we were to go out and grab 100 samples, we'll say, we would find that the difference of those 2 groups would be between these 2 values for 95 of those groups. And for the other 5, they won't be contained. That difference won't be contained in this interval. Okay. And that's kind of what this is saying. Our 95% confidence interval is saying if we were to go out and get a similar size sample and an infinite amount of times, that 95% of those times, the difference between the 2 groups that we're testing will be contained in this interval. And then 5% of the time they won't be. Okay. And that's a pretty big deal. 95% chance is like pretty certain. You know, that happens pretty frequently, which is great, we are also able to look at the overall difference between the 2 samples, kind of reflected as the standard error units, and we are also able to see the means of both of them. Oh, man, it's crazy. So we go back to Darwin, old Chuck, and he's yeah, he's looking at your TV as if he's never seen one, because he has not. And we say, okay, since the p-value is less than 0.05, now we can say, you know, we can be statistically accurate here, or we can be kind of practically, you know, minded in how we say this. So in Stat 2050, since the p-value is less than 0.05, we would say we reject the null hypothesis. In Stat 3050, we would say there is a difference between the 2 groups. Okay. And then what is the difference? Well, the difference in mean, actually, we got to go back. The difference in means, yeah, we have to do a little bit of math. Not that big of a deal. So it's just 20.19 minus 17.58. Whatever we'll just say for right now, it's approximately about 3 inches. Very cool. And is how many standard error units away from 0? Well, in this case, we would just look at the t value, 2.43. 2.43. Okay. And again, you can take this sort of template here and use it for your homework and lab and whatever else. I'm totally okay with that. And then we can be what percent confident? We can be 95% confident that the true difference in means in the population is contained in these, between these 2 values. Let me go back here. Is between these 2 values. So 0.38 and 4.8. We'll just say that. So 0.38 inches, units are very important, to about 4.8 inches. Oh my gosh, look at that. We were able to get so much information with just that one single line, that one fairly easy test, okay? We were able to get a bunch of information about the whole population based on our decently, not super small, but not large. We were able to make a pretty good conclusion here based on our sample, right? And we were able to infer on how the population behaves. Oh my gosh. Anyway, so old Chuck says, that's great. Now can we I can't believe I wrote this. Now we can watch Game of Thrones. I'm on season 3 now, he says. And then of course, anyone who's seen Game of Thrones knows that you just don't watch the last season. You just left up to the unknown. Okay. So let me see what we got next. Okay. So again, this is a lot of information, but we're going to get a ton of practice here in homework and in labs and in class too. If you have any questions, please just let me know. But in a little recap, we ran a quick t-test on the 2 columns of data. And we were able to answer the question, are these 2 different fertilization methods, I guess, are they different? Do they result in a different height across plants? And since our p-value here is decently small, smaller than 0.05, then we say, yes, there is a difference, okay? And in our sample, that difference was about 3 inches, okay? But we know that that might not be true across the whole population. In fact, what we will then say is that we know we can be at least 95% confident. There's a 95% chance that that true difference in the whole population between all of the pea plants that are cross-fertilized and pea plants that are self-fertilized, we are 95% confident. There's a 95% chance that that difference is contained in this interval here. Oh my gosh. And that's pretty much that. So we just made a bunch more money, I think, and we made a good friend, old Chuck Darwin, along the way. So with that, we'll move on to some different types of t-tests, and and we will we'll see you in the next one.